Support for WUWM podcasts comes from Potawatomi Casino Hotel Milwaukee, home to 24/7 excitement, dining, and an on-site hotel at 1721 West Canal Street. More information at potawatomi.com.
Lake Effect brings you conversations about what's happening in Milwaukee and the people, places, and organizations that shape the community. This is Lake Effect Spotlight from WUWM, Milwaukee's NPR.
October marks the start of the respiratory viral vaccine season in earnest. Illnesses like the flu, COVID, and RSV are making the rounds. Fortunately, there are tried and tested tools to help us stay healthy while protecting others, like vaccines. To go over the vaccines that are available, how they work, and the importance of getting your annual shots, Dr. Jim Conway joins me now. He's the medical director of the UW Health Immunization Program, and he begins by explaining what factors contribute to the flu and other illnesses peaking at this time of year.
A typical season is sort of associated with a couple of things. One is the change in the ambient humidity and the air temperatures, and those actually seem to be more amenable for viral persistence when they get to be dry and cold. So it's almost like it acts as a preservative, and a lot of these viruses end up on the surfaces where they can then persist a little bit better. There's less sunlight, there's less ultraviolet light with the sun that kills them, and so they're able to persist. Then you get the combination of people touching those things and touching their faces and rubbing their eyes and things like that. And then you put people into closed spaces where the windows are closed and they're in largely congregate settings, and boom, you've got the perfect opportunities then for viral transfer. Schools certainly contribute to that. The holiday season in November and December contributes to that. And so you put all those things together and we get a very predictable sort of winter flu and cold season. I think the thing that's been really interesting is that COVID taught us there's also other times of the year when that same thing can happen. And so we see these summer peaks with COVID. And if you think about it, you close the windows, you turn on the air conditioning takes the humidity out of the air, and lo and behold, you've actually created similar conditions that also allow for viral persistence, put people in closed settings, in close proximity, and so you can get these off-season outbreaks as well.
In order to combat these outbreaks throughout the year, a lot of people, we get vaccinated, there's masking, social distancing, a lot of these lessons we carried from the heat of COVID. But let's go over some basics about vaccines before we get into individual types. So how do they work, and how are vaccines studied and improved over time?
Yeah, so vaccines are basically designed to kind of trick your immune system into thinking it's already had a disease previously that hopefully it hasn't had. So we all generate some immunity after we have what are called wild type diseases or naturally occurring diseases, and we have some persistence of that immunity. And the idea for vaccines is to try to mimic that, to develop something that turns on those same pieces of the immune system without subjecting the person to having to deal with all the ramifications of actually getting sick with the illness. We know that by turning on the immune system, you may have a little bit in the way of mild side effects that often are associated with the illness itself. But in general, they're much, much more mild than the actual infection itself. As far as the testing of vaccines, it's interesting because vaccines are held to a very different standard from most pharmaceutical drugs. So they're tested in much larger populations. If you think about drugs are often tested in 10 or 15,000 people. Vaccine trials generally have 70 to 100,000 people in each arm of the trial, as well as then longer term monitoring for both short and long-term side effects. So part of the reason when people ask, like, why are vaccines so expensive, it's because the amount of work that goes on either in academic settings or by the pharmaceutical industry really demands it, because they have to cross every T and dot every I.
Now, there is a wide range of ages and populations that benefit from vaccines, but which populations are at a higher risk of developing serious illness when either they're not vaccinated or when people in their communities are not vaccinated enough?
Yeah, so I think the groups we worry about are the people whose immune systems aren't quite up to snuff, and that includes obviously people with immune suppressive conditions or immune suppressive drugs, people that have had transplants, people that have cancer and are on chemotherapy, people with HIV/AIDS. There's a whole litany of those kinds of conditions, including people with now more and more of these autoimmune diseases that are on various biologic products. But the beginning of life and at the end of life, you also have a pretty diminished immune system. So we talk about immune senescence when you get into older populations. And then when we talk about young children, they're really a work in progress when it comes to their immune system. And so it really takes until the second or third year of life before a kid's immune system is really fully functional. So those are the primary groups we worry about when we worry about either acquiring a disease or having unfortunate and more severe outcomes from these diseases.
So let's go over what vaccines are now widely available and recommended. And we'll start with COVID-19. What's kind of the latest strain of the illness like, and are there any different characteristics being reported?
Yeah, I mean, these viruses keep mutating. I think one of the things we've learned is that they're not very smart and they make a lot of mistakes. And so we do end up with a lot of different mutants circulating at any given time. I think people got used to the whole alpha, beta, gamma, and now up to Omicron. We've sort of been stuck on Omicron for a long time, partially because it's towards the end of the alphabet. We're not sure where we would go after that. But we now have all these subtypes of Omicron that are circulating. And the way it works is basically WHO and FDA advisors have to look sort of in the spring, usually, as far as what they can see happening right now and what's circulating currently, and then try to forecast as we learn more about how these things mutate, what things are going to look like when we get into the peak of the season, because you've got to develop a recipe and then share that with the manufacturers so they can kind of make their best attempt at making one of these vaccines. The current COVID vaccines are really designed as a monovalent vaccine. So they've chosen something that's highly prevalent globally, that is relatively stable, but that also offers some cross protection so that as you develop immunity to that, you also hopefully have some cross protection that as the virus changes, that immunity will still hold up even if the virus changes a little bit. And so we've got monovalent vaccines right now that are available for a number of different models, but the primary ones that are going to be out there and available are using the mRNA technology.
So there's been some uncertainty and confusion with whether most people with health insurance can get the COVID vaccine after the CDC adopted its vaccine advisor's note to shift away from broad recommendations. So what's your current understanding for access to this vaccine? And is a prescription needed, or is it still kind of the norm that we've had these past few years where you can go into your local pharmacy and get it along with a flu shot?
Yeah, I certainly understand that it's been confusing because it's been a deluge of information for everybody to try to digest. But, to really simplify things, the companies that develop these vaccines each year then have to have FDA approval. And the FDA sort of made an unusual move in that they essentially said that they really thought that the priority should be in these higher risk populations. And they called those people over 65 and people with underlying comorbidities or coexisting medical conditions. In response to that, then the major professional medical societies, the American Academy of Pediatrics, American Academy of Family Physicians, American College of Obstetrics and Gynecology, responded by coming out with their own recommendations on who they thought the vaccines should be used in. And I think it's a good reminder for people that that's actually always been the way things have been, that pretty much every year all these professional societies have made their recommendations. I think what we've all gotten a little bit lulled into a false sense of security over is that the Advisory Committee on Immunization Practice, the infamous ACIP, has generally taken those recommendations and sort of harmonized them and made similar recommendations. And so people were worried that we might be ending up with this balkanization of the recommendations where we'd be getting different recommendations from different organizations. One of the things that was really interesting at the meetings on September 18th and 19th was that the ACIP, even despite being reconstituted with, some people that are questionable as far as their scientific understanding of really the depth of vaccines that most of the previous group had, even they couldn't rebut the bulk of data and the information that was out there, and basically came out with a recommendation that everybody over 6 months of age should have access to and should be entitled to the opportunity to be vaccinated with the COVID vaccines. And was, I'll admit, a little bit of a pleasant surprise, but it also really suggested how strong the data and how strong the recommendations were from those professional societies. So those recommendations then were adopted by the acting CDC director as officially CDC and HHS Health and Human Services policy, which basically means Medicare and Medicaid and all the insurers are covering COVID vaccines this year for everybody 6 months and above. The one thing that they did, which was a very subtle nuance, was as opposed to routinely recommending these for everybody, they basically put these into a category that we've been using for years now that's called shared clinical decision making, which basically says you really can't require these. These should be things that people have an opportunity to ask questions about. But if somebody decides they really want it, and if their provider thinks that it's the right thing for them, that everybody should be entitled to get these. So at the end of the day, these are basically going to be business as usual operations for all of us. Everybody can get these vaccines. Certainly, I believe everybody should get these vaccines, and every insurer is going to be able to provide these vaccines.
I'm just going to take a moment to reintroduce you. You're listening to Lake Effect. I'm Audrey Nowakowski speaking with Dr. Jim Conway. We're going over vaccinations as peak flu season is coming up, along with other illnesses. So we just covered COVID-19 and the latest vaccine for that. Let's go to the flu shot or influenza vaccine. So what is influenza and what's the difference between that and the common cold people might experience?
Yeah, so influenza viruses have been around for, centuries as far as we know. And one of the interesting things about influenza viruses is that they can jump around between different species. But the unusual part about it is that as it jumps around between animals, it can recombine. And so often these things recombine in either swine or in birds. And so when we hear about swine flu or avian flu, those are by virtue of the fact that those animals can be infected by human flu, by porcine or swine flu, and by avian flu. And so you essentially get this sort of mixture of these things that allows these viruses to recombine and then new things pop out. So the problem with flu when it hits is that it can be pretty unpredictable how it's going to act any given year because of this recombination. And then during the season, they're also constantly making mutations. And so we talk about the constant drift and shift that influenza is going through as it circulates around the globe. As far as a disease, I mean, it certainly can start out seeming like the common cold with, a runny nose and a little bit of cough. But people with flu, unlike those with just the common cold, get high volume of virus in their bloodstream. It can sort of land everywhere. It turns on your response system and your immunologic system really pretty robustly. And so you get a lot of release of chemicals called cytokines that give everybody that bad headache, that really achy feeling. And then that inflammatory response, unfortunately, leads to pneumonia in some people. And those pneumonias then set people up for secondary pneumonias caused by bacteria and sometimes even fungus. So it's a really complicated world of influenza, but we're fortunate that we've worked out a way to protect people with vaccines. Those vaccines, similar to COVID vaccines, have to be updated every year based on what the anticipated circulating strains are going to be. The biggest improvement that's happened, in the last 15 years has been the ability to create what are called the enhanced influenza vaccines that are really designed for those older individuals who have relatively poor immune responses. And so this started with the high dose influenza vaccine. There's now some adjuvanted vaccines that are basically designed to help people whose immune system might not respond as well to the standard dose vaccine to get a little bit more oomph to their immune response and get them better protection. So for people over 65, I really strongly recommend that they make sure they're asking for an enhanced influenza vaccine and not just settle for the standard dose at this point.
It's definitely a good tip to keep in mind. Another thing that's coming up a little more frequently right now is RSV. What is it and what population does this impact the most?
Yeah, respiratory syncytial virus was something that was sort of one of those inadvertent, I wouldn't say discoveries, but reminders that happened during COVID, that as we started testing more people with rapid tests that essentially were built on a platform that used to have RSV and influenza on it, the easiest thing to make readily available tests available for everybody was to basically just add some COVID into that. Typically, those respiratory tests weren't done during the summer when these viruses weren't common. Well, suddenly the pandemic shows up and we're testing people year round, and we discovered that RSV is a lot more common during the year than we actually realized, and that it really is a major source of disease for older individuals, similar to what influenza does and what COVID does. So we had, for many years, been focused on just small premature babies as the ones that seem to have a lot of problems with RSV. And so we had been giving versions of monoclonal antibodies to newborn babies, especially premature babies and babies at high risk, to protect them against the really severe lung disease that RSV can cause. But there were a lot of companies and a lot of researchers that were interested in seeing if there was a better way of providing protection. And they actually finally did come up with some actual vaccines. And so we've now got vaccines that are routinely recommended for everybody over age 65, are recommended for people that have other high risk conditions that are over age 50, and then actually can offer one of those vaccines for people during the end of their pregnancy that basically gives mom some immunity that can be passed to the baby before the baby's born. But fortunately, if that doesn't happen, or if there's concerns or questions about doing that in a pregnancy, there are now these routinely available monoclonal antibodies that are available. And no longer are we just focused on premature babies. We actually now can give those to every newborn infant, and even some kids during their second year of life that have high risk conditions. And it's really changed the game fairly dramatically. And so I really, suggest very highly that, again, the same people that are at high risk for flu and COVID should really be asking about RSV for themselves as well. The only thing we don't know because of that accelerated development is when boosters might be needed. So right now, for the older population, it's basically a one and done for now, while we wait and see how long does that immunity last. Looks like it lasts at least 3 or 4 years. And so I'm guessing that at some point in the next couple of years, we're going to start to have boosters. I have no idea, honestly, what that's going to look like, but I would guess probably every 5 years might be reasonable, and we'll have to kind of let the science tell us ultimately how that really should be done.
With flu season coming up and a number of illnesses people want to fortify themselves against, you might be getting one or maybe multiple vaccinations at your doctor's office or pharmacy. So, what are some common side effects from vaccines that people might experience?
Well, I mean, it hurts to get a needle stuck in you. So, I think everybody has some element of hesitancy about getting needles stuck in them. There's, certainly going to be some pain at the injection site. That's kind of the first thing that people complain about. Some people do get a little achy as it sort of activates their immune system. And again, it's sort of simulating a mild version of whatever that illness was. And so I'd say, a decent number of people, 10 to 20%, are going to have sort of an achy feeling for a day or two afterwards. The enhanced potency influenza vaccines have a little bit more of that than the standard doses. But I think for the majority of people, these hopefully are becoming routine and they're really not that severe. And with a little bit of Tylenol or ibuprofen, most people can tamp down those symptoms and manage it without too much difficulty. The other thing to remind people about, and I forgot to mention before, is that for people that are really needle phobic, there are nasal flu vaccines for influenza as well. Those can be obtained, at pharmacies and at providers' offices. And there's actually a new program where people can actually order and receive what's called Flu Mist, a nasal flu vaccine at home that they can self-administer. So that at least gets them over one of those shots. But currently for RSV and influenza and for COVID, sorry, that's really the only option you have is an injectable version. There may be at some point in the future different versions of delivering those, but right now we've got pretty good tools and might as well use what we've got.
As people may be planning when it's best for their next vaccinations, can you share how long it typically takes for any given antibodies to build up?
Yeah, it's usually a process about 5 to 7 days of your immune system sort of ramping up and different parts of your immune system talking to each other and getting everybody on board. I'd say usually within about a week, you've got pretty good immunity, and certainly by 10 to 14 days, you've got the full immune response that you're going to have. And so that's part of the reason that I think as you're getting towards, we want people to start thinking about this sooner rather than later, because it does take time for everybody to get scheduled in and get managed. And so the sooner we can get communities and families started on this, we can get through everybody, hopefully, as we get towards the beginning of November. So everybody's prepped before we get into that holiday travel season where everybody insists on hugging each other and kissing each other and providing lots more opportunities to trade these viruses around.
Well, Dr. Conway, thank you so much for joining me today to explain more about vaccination and vaccines in general as we are ramping up into flu season.
Thanks for having me, Audrey. I appreciate your helping everybody understand this. And, the more people that get covered and vaccinated, the more immunity we have within our households and our communities, the smaller the outbreak we're going to have. And hopefully we can have a relatively mild season, but we can all contribute to that, both by getting vaccinated and hopefully continuing some of the stuff we did during COVID. When you're sick, please try to stay home. Don't be a hero. Don't go to work. Don't go to school. And if you do have to go out, and certainly many people do, wear a mask when you're out there. It's courteous to others, and it really will help tamp these things down and prevent our communities from being really potentially devastated from some of these big outbreaks that we might have to deal with.
Dr. Jim Conway is the medical director of the UW Health Immunization Program and an infectious disease physician with UW Health Kids. You can listen to more of our conversation and find resources at wuwm.com.
You can find more interviews like this one by visiting wuwm.com/Lake Effect. And while you're there, subscribe to the Lake Effect Spotlight podcast.